Okay, on to page 4. Solve the equations. Determine all the solutions in a. So this is another solving equations. So I'm going to have to isolate this. Now I'm looking ahead. This one just has one trig function, tangent of x. This has one, but it's being squared. This one, there's two trig functions, cosine squared and cosine. This one I'm going to have to factor. These two I'm going to be able to get it by itself. So let's look at that. Tangent of x. If I move the negative square root of 3 over, and I divide by the 3, I'm going to end up getting that the tangent of x equals a positive square root of 3. That's what happens when I move that one over. And then I divide by that 3. I'm going to get square root of 3 over 3. Now, I go back to what we did on page 2. And if I have 1/2 over the square root of 3 over 2, in terms of the x's and y's, that will give me 1 over the square root of 3, which rationalizes to be square root of 3 over 3. So I'm looking for where I have 1 over 2 over square root of 3 over 2, and that's the y value, and that's the x value. So I look at my unit circle. Where do I see a y value of 1/2? And this is positive. So it's either got to be a positive over a positive or negative over a negative. So y is 1/2. That's right here at pi sixths. So pi sixths. Okay, and then I remember if I take this and I reflect it all the way over here, I get 7 pi sixths. There's my other one. And a negative divided by a negative, that's going to give it to me. So 7 pi sixths. There are my solutions. Okay. 2 sine squared of x minus 1 equals 0. So if I add 1 and then I add 1, that's going to give me equals 1, right? And then I divide by 2, I'm going to end up getting that sine squared of x equals a positive 1/2. But then I got to take the square root of it. Well, the square root of 1/2 is 1 over the square root of 2, and rationalized, that becomes the square root of 2 over 2. So that's what I'm looking at. But it's got to be positive and negative, because when I took the square root, there's always two roots. So a positive and negative square root of 2 over 2. Now, if you have a rough time doing this, type that square root of 1/2 into a good calculator, and it'll give you square root of 2 over 2. See, watch. Square root of 1 over 2 gives me square root of 2 over 2. There we are. Where is that happening on my unit circle? Well, here at pi fourths, here at 3 pi fourths, so y is square root of 2 over 2. Y is negative square root of 2 over 2. Here at 5 pi fourths, negative square root of 2 over 2. And over here, this is 315 degrees, and 5 pi squared, 7 pi fourths. So my solutions are pi fourths, 3 pi fourths, 5 pi fourths, and 7 pi fourths. There it is. All 4 of them, because I needed the positive and negative square root of 2 over 2. Now check this out. Cosine squared cosine. This is a trinomial. So I'm going to factor this. 2 cosine of x, cosine of x. Because 2 times 1 makes 2. Okay? Now, I've got to think these numbers have to be multiplied to make a negative 2. So I know it's going to be a plus and a minus and a 2 and a 1. If I do, well, I can't do a 2 here, so the 2's got to go over here. I know I can't do a 2 here because that would be a common factor, and there's not a common factor in these. So it's got to be a 2 and a 1. And 2 times 2 makes 4. 1 times cosine makes 1. 4, 1. Oh, it's got to be a negative 2 and a positive 1. See, check it out. 1 times negative 2 makes negative 2. 1 times cosine makes 1 cosine. Negative 2 times 2 cosine makes negative 4 cosine. And 1 cosine minus 4 cosine makes the negative 3. Now, I take each one of these and set them equal to 0. Okay? So this cosine of x, I move the 1 over, it becomes negative 1, and then I divide by the 2, and I get cosine of x equals negative 1/2. This one, I move the 2 over, cosine of x equals 2. Well, on my unit circle, remember, this is the x value. I never have an x value of 2. So this one will have no solutions. But this one, where's my x value of negative 1/2? That's going to be right here at pi thirds. So pi thirds. And if I reflect that over the x-axis, I get down here to 4 pi thirds, which is, again, an x value of negative 1/2. So pi thirds and 4 pi thirds. That's where the x value on the unit surface, that's the x value in the unit circle, because the cosine is the x value. Now, graphs. Midline. I look at this and I see the line right down the middle. That's at -2. Midline is at -2. The amplitude from here to here, that's the amplitude. That's 1, period. Start there, and I need to go until I hit the midline again, and it repeats. See, it hits it here, but it's going up, and it started by going down. So down, up, down, right there. See where I'm at? I'm at 2. That's the period. Now, this is a sine curve because it hits the axis, but see, a sine curve would start by going up. This starts by going down, so it's a negative sign. So negative, the amplitude, go f of x equals, the amplitude is 1, so -1 times the sine. The midline's out here, -2. There's going to be an x in here, but the number here, remember, you get the number here by going 2 pi divided by the period. Well, 2 pi divided by 2 is pi, so this is just pi times x. So if I know the period, I go 2 pi divided by the period. That gives me this number inside. I know it's sine because a cosine would start kind of up here and go like that. Okay, so this, I'm looking at here. My midline, I can see it goes right down the middle. But now see how this starts below? It doesn't start on like this one did. This is a cosine. In fact, it's a negative cosine. So I'm going to start by going negative cosine. I need to fill some things. Okay, the midline, it's at 1, 2, 3. So that gives me +3 out here. The midline is 3. The amplitude, from 3, 2. The amplitude is 1 because it's only 1 distance from there to there. The period, I start here and I wait till I get to that same point right there. The period's 2 pi. So this number inside here is 2 pi divided by the period, which is 2 pi. Well, 2 pi divided by 2 pi is 1. So this is 1x. So there it is. F of x equals negative, amplitude is 1. So this is -1 cosine times 1x of 1x plus 3. So I probably, if I want to make it prettier, I'll just go negative cosine of x plus 3. And that's it. Okay, that's it for page 4. Okay, guys, on to page, this is page 5, isn't it? Okay, on to page 5. We're back to logs. Cool. Graph the function log base 4 by creating a table of values first, then plot the point in the graph. Okay, I'm going to do this maybe a little out of order because, first of all, I know that the graph of a log looks like that, okay? It's helpful to know your parent function. I know that the graph of a log, unless it's being shifted up, down, right, or left, there's going to be an asymptote right there at x equals 0 because the inside of a log, the x value here can never be negative, so it can't be over here. In fact, it can't even be equal to 0. Now, the domain of a log is going to be 0 to infinity. The range of a log is going to be -infinity to infinity. This will always be the range because it's always going to go up forever and down forever. However, I could take that graph, I could take this graph and shift it up and over, or up and down, or whatever. But the range will never change. The domain might change. Now, let me show you this. This is the same as y equals a log base 4 of x. I can start putting things into that function in my calculator and get some stuff, but by hand, or even so it's clear to understand, rewrite it as an exponential. This goes 4 to the power of y equals x. Now, this I can do in my head. For example, if I put a 1 in there for the y value, 4 to the power of 1 is 4. So this goes through the point 4, 1. 1, 2, 3, 4, 1, right there. If I put a 0 in there for the y value, so here's the thing. I can put numbers in here for x, use my calculator to come up with this stuff, but you're going to get some ugly numbers. If you want your numbers nice and pretty, rewrite it into an exponential equation, and then put numbers in for the y. So if I put in a 0 for the y, 4 to the power of 0, well, 4 to the power of 0 is 1. So this is going to go through the point 1, 0. If I put in a 2, 4 to the power of 2 is 16, which is way over here. If I put in a power of -1, 4 to the power of -1 is 1/4. So this is going to go through 1/4 -1 right there. If I put in a -2, 4 to the power of -2 is 1/16, which is even closer. So my graph looks a lot like that. You're never going to cross this vertical asymptote, and it's going to have that shape. Okay? If you choose to put in values of x, put in multiples of 4, 1, 4, 16, 64, 1/4, 1/16. If you put in numbers like 2, 3, 5, you're going to have some ugly y values, but it will still work. Okay? Now, if I do this, x plus 4 plus 1, this plus 1, that's going to shift it up 1. This plus 4, that's going to shift it, sorry, you can't see that. This plus 4, that's inside, so it's moving opposite, so that's going to shift it left 4. Check this out. If I take every one of these points up here, I'm going to do this a little out of order, and I go up 1 and left 1, 2, 3, 4. Put that point. Up 1, left 1, 2, 3, 4. Put that point. Up 1, go left 1, 2, 3, 4. Put that point. Take the asymptote, move it up 1, which is not going to change a thing, and go left 1, 2, 3, 4. My asymptote is there. It's now at -4 instead of 0. This point, up 1, left 1, 2, 3. Up 1, move 1, 2, 3, 4 right there. There it is. My graph has been shifted up 1, left 4. The range is still -infinity to infinity. The vertical asymptote is x equals -4 because it was moved left 4. So instead of at 0, it's now at 1, 2, 3, -4. My domain is now not from 0 to infinity, it's from -4 to infinity. The domain always is going to start at the asymptote. Guys, that's it. That's the whole test. Good luck.